Listening to the Stars, presented by Science at NASA. In 1947, shortly after the end of World War II, a young radio astronomer in Australia named Ruby Payne-Scott was observing the sun when a tremendous roar of static issued from the loudspeaker of her radio telescope. Almost 70 years later, astronomers are still marveling at the outburst. It was so intense, says Greg Hallinan of the California Institute of Technology, it could have been detected from other stars light years from Earth. Back in Payne-Scott's day, solar radio bursts were a new thing. During World War II, engineers had noticed noisy outbursts interfering with radar and radio communications. What could turn the sun into such a powerful natural radio transmitter? Ruby Payne-Scott wanted to find out. Hallinan is fascinated by the story of Payne-Scott. Often the only woman in her physics classes at the University of Sydney, she became a top-secret radar expert during World War II and is widely considered to be one of the finest physicists in Australian history. She was the world's first female radio astronomer, and this was a cutting-edge research problem. The sun emits radio bursts almost every day, but many of them are relatively weak. The burst of 1947, however, was a record-setter. No one had ever heard anything like it, nor did they understand it. Now we believe it was caused by a ferocious CME, explains Hallinan. Coronal mass ejections, or CMEs, are billion-ton clouds of plasma that billow away from the sun in the aftermath of magnetic explosions, often, but not always, in tandem with a solar flare. CMEs hitting Earth can spark geomagnetic storms and northern lights. CMEs often announce themselves with a burst of radio waves. The emissions are caused by shock waves in the leading edge of the cloud, which plow through the sun's atmosphere at supersonic velocity. Today, NASA has a fleet of satellites in space to observe these explosions on the sun. Scientists work to better understand what causes them so we can protect our satellites from surges of unexpected radiation. But studying our sun has bigger implications as well. It gives us the insight into the workings of stars all around the galaxy. Fast forward to 2015. Deep in the heart of California's Owens Valley, a strange-looking telescope stands in the desert landscape. It is an array of 288 TP-shaped wire frames, staring into the sky overhead and hearkening back to the days of Payne-Scott. This new radio telescope, called the Long Wavelength Array, or LWA, is designed to detect the same kind of powerful outburst Payne-Scott recorded in 1947. Except not from the sun. We are looking for CMEs around other stars, explains Hallinan, the instrument's principal investigator. When the array began normal operations, it started mapping the sky every night, listening for shortwave radio bursts from more than 2,000 nearby stellar systems. Although rare, with such a large sample, these radio outbursts could be detectable on a regular basis. Hallinan says, we think we will be able to detect CMEs, especially from the active M-dwarf stars that make up 75% of our sample. But CMEs are just the beginning. The array might also find planets. When CMEs hit planets in our own solar system, the planets themselves emit low-frequency radio waves as their magnetic fields reverberate from the impact. The radio emissions come from auroras circling the magnetic poles. Any planet with a magnetic field can produce this kind of CME echo. The LWA is listening for these echoes, potentially unearthing new worlds in distant star systems. After some preliminary observations to test the hardware, the array went into full science mode in late 2015. Nightly observations will continue for the next 2 years. A discovery by the LWA could ring even louder than Payne-Scott's original outburst. Stay tuned for updates from science.nasa.gov.